Dear students, welcome to digital classes. In 9th class, today we are going to start an interesting and important topic, triangles. In your earlier classes, you have already learned the basic concepts of triangles, properties of triangles, and some concepts related to the triangles. Now in 9th class, triangles, we have the following concepts: introduction to congruency, criteria of congruency and their applications, and third topic, inequalities of triangles. In this session, I am going to explain introduction to congruency. Let us observe the following pictures. Students, observe the pictures. I think all of you are very familiar with this picture. What is its name? Yes, it is a land phone. Now what you observe in the picture? Yes, they look exactly same. So in geometrically, their shape and sizes are same. Means the appearance, the shape and sizes are same. Now I am going to put the land phones one over other. If they are exactly overlap each other, then they are congruent. Let us check whether they are congruent or not by putting overlap each other. Students, observe the picture. Yes, they are exactly overlap each other, hence they are congruent. Now observe the second picture. So what do you observe in the picture? Yes, they are wooden houses. And observe, they are in the same shape but different sizes. The sizes are different but the shape is same. Now what do you think about their congruency? Let us check by putting one over other. There the shape is same but sizes are different. If I try to put their one over other, they are not overlap each other. Hence they are not congruent. Now observe the third picture. Students, observe carefully. See, in the first row, the three toys are in the same shape and in the same size, whereas in the second row pictures, their shape is same but sizes are different. Now what about the first row pictures? Are they congruent? Let us check whether they are congruent or not by the same process, overlapping each other. Yes, they are overlap each other exactly, hence they are congruent. Now what about the second row pictures? Are you think they are congruent? Let us check. Yes, they are not overlap each other, hence they are not congruent. Now from above all these examples, we observe the following. The objects which are in the same shape and in the same size are known as congruent. Now see the definition, the congruence. Congruence is a simple but fundamental concept of geometry. The two geometric figures are said to be congruent if they are exactly of the same shape and same size. While comparing the figures geometrically, we have to compare only their shape and size. Means if the shape and sizes of two geometric figures are same, then they are congruent. The congruent means equal in all aspects. Such figures can be superimposed on the other to cover it exactly. Let us discuss some daily life examples. If two new 10 rupee notes placed one over other, they cover each other completely. Now see students, this is the first 10 rupee note and this second 10 rupee note, and see, observe, yes, they cover each other exactly, hence they are congruent. Now the second example. Similarly, your 9th class mathematics textbooks also congruent. Observe here there are two 9th class mathematics textbooks, and observe they perfectly overlap each other, hence they are congruent. Now see, two photographs of same size from the same negative are congruent. See, this is the first photograph and this is the second photograph of the same size, and see here they overlap each other exactly, hence they are congruent. The symbol used for the congruence is, so this is the symbol we use to denote the congruence. Let us discuss some mathematical examples. Line segments. In your earlier classes, you have already learned the concepts of congruency of line segments. Now see, the two line segments are congruent if they have equal length. Means while comparing the congruency of two line segments, if they have equal length, then they are congruent. See, observe here, the AB is a line segment of length 5 centimeters, CD is another line segment of length same 5 centimeters, and PQ is a line segment of length 4 centimeters. Now student, identify the congruent line segments. Yes, AB and CD are congruent line segments because they have equal in length. AB line segment length 5 centimeters, CD line segment of length 5 centimeters, hence they are congruent, and we denote mathematically like this: AB is congruent to CD. Now my question, what is the relation between AB and PQ? Are they congruent? No, because yes, they have not equal length. AB is 5 centimeters and PQ 4 centimeters. They are in different length, so they are not congruent, and we denote like this: AB is not congruent to PQ. Now see the second example, angles. Two angles are congruent if their angle measure is same. See children, here the first angle, angle ABC of 30 degrees, and angle DEF of 30 degrees, and XYZ is of angle measure 60 degrees. Now children, identify the congruent angles. Yes, angle ABC and angle DEF are of equal measure 30-30, hence they are congruent, and we denote here like this: angle ABC is congruent to DEF. Now what is the relation between the angles DEF and XYZ? Are you think they are congruent? No, because their angle measure is different. The angle DEF is of 30 degrees and angle XYZ is of 60 degrees. So they have the different measure, so they are not congruent, and we denote like this: angle DEF is not congruent to angle XYZ. Now observe the third example. Now how to define the congruency of two circles? The two circles are congruent if they have equal radii. See children, radius means singular form, radii means plural form. While comparing the congruency of two circles, we have to compare their radius. See, C1 is the first circle of radius 3 centimeters, C2 is a second circle of radius 3 centimeters, and C3 is a third circle of radius 5 centimeters. Now in the same way, student, identify the congruent circles. Yes, C1 and C2, the two circles of equal radii, hence they are congruent, and we denote like this: C1 circle congruent to C2 circle because they are equal radii. Now what is the relation between the C1 and C3 circles? Are they congruent? No, because they have different radii. See, C1 of 3 centimeters radius and C3 radius is 5 centimeters. So they have different radii, they are not congruent. So C1 circle is not congruent to C3 circle. Now observe the fourth example related to squares. The two squares are congruent if they have equal sides. Equal sides means the length of the sides are equal. See here, ABCD is a first square of length 3 centimeters. EFGH is second square of length 3 centimeters. PQRS is the third square of length 6 centimeters. Now same way, student, again here also identify the congruent squares. Yes, ABCD and EFGH, two are congruent squares because their side length is same, 3 centimeters, 3 centimeters, and we denote like this: square ABCD is congruent to square EFGH. Now again, so what is the relation between the squares EFGH and PQRS? Are you think they are congruent? No, because their length measure is different. The square EFGH of 3 centimeter length, the square PQRS of length 6 centimeters, so they are not congruent, and we denote like this: the square EFGH is not congruent to PQRS. Note, in general, sides decide sizes, angles decide shapes. Means for two geometric figures, the sides decide its sizes, and the shapes of the geometric figures decided by its angles. congruent triangles. See the statement. If two triangles are congruent, then the sides and angles of one triangle are equal to the corresponding sides and angles of the other triangles. See student, while comparing the congruent triangles, we have to compare totally 6 equalities. Means first we have to compare the three sides. If the corresponding three sides of two triangles are equal, if the corresponding three angles of the two triangles are equal, then the two triangles are congruent. Let us discuss with an example. Observe here a triangle ABC and a triangle PQR. Are you think they are in the same size and same shape? I think it is somewhat difficult to decide. Now I am going to put the triangle PQR on triangle ABC by rotating the triangle PQR in a clockwise direction 2 times. Now student, observe carefully. See, here I am rotating the triangle PQR from the vertex P. So this is the first rotation and it is the second rotation. Now I am going to put the triangle PQR on triangle ABC. Observe carefully. Yes, the triangle ABC and the triangle PQR are overlap each other exactly. Now we have to observe here the 3 things. The first thing, now students observe here the vertex A is covered by vertex P and the vertex B is covered by vertex Q and vertex C is covered by vertex R. So vertices are covered each other. Now what about the sides? Now this is the second observation. Observe the sides. In triangle ABC, the side AB is covered by side PQ. Here the side BC is covered by the side QR and the third side CA is covered by side RP. So the sides are exactly covered. Now this is the second observation. Now observe the third observation. What about the angles? Yes, the angles are also covered each other exactly. See, the angle A is covered by angle P, angle B is covered by angle Q and angle C is covered by angle R. So these are the 3 observations. Now I am going to put the triangle PQR in its original position by rotating anti-clockwise direction. Now note down all the 3 observations here. So same the previous triangles, triangle ABC and triangle PQR. Now write one by one. The first observation, now we observe the first observation is the vertex A is covered by vertex P. Here the vertex A is covered by vertex P, means there is a one-to-one corresponding between the vertices and we denote like this. A corresponds to P. We use the symbol 2 sides arrow marks to denote one-to-one correspondence between the vertices, because the vertex A is covered by vertex P, so there is a one-to-one correspondence between these 2 vertices. Now in the same way, the vertex B is covered by vertex Q, so here also there is a one-to-one correspondence between B and Q and we denote like this, B corresponds to Q. Similarly, the vertex C is covered by vertex R, so there is a one-to-one correspondence between the vertices C and R and we denote like this. So this is the first observation. Now observe the second point. So just now we observe about the sides. In triangle ABC and in triangle PQR, the side AB is covered by side PQ. The side AB is covered by PQ, means their length measure is same. Means if the line segments of equal length, then they are congruent. And here we discuss about the congruent of sides, congruent of angles and congruent of triangles. See here, just now we observe the length of AB is equal to the length of PQ, means they are equal length and we denote like this, AB equal to PQ. And just now we observe the side BC is covered by side QR, means their length of measure is same, equal length, means they are congruent and we denote like this, BC is equal to QR. Similarly, students observe the side CA is covered by side RP, means they have equal length, means 2 line segments of equal length, then they are congruent. means they equal length, and we denote like this, CA equal to RP. So in two triangles, the three pairs of corresponding sides are equal and they are congruent. Now what about the angles? Yes, the angles are also congruent, because just now we observe the third point, the angle A is covered by angle P. Angle A is covered by angle P, means their angle measure is equal. If two angles measure is equal, then they are congruent, and we denote like this, angle A equal to angle P. Similarly, the angle B is covered by angle Q, means their angle measure is also equal, hence they are congruent, and we denote it like this, angle B equal to angle Q. And similarly, the last angle C is covered by angle R, so their angle measure is same, hence they congruent, and we denote it like this, angle C equal to angle R. Now students, observe, in triangle ABC and in triangle PQR, here the sides are congruent and angles are congruent, hence these two triangles are also congruent. Means if sides are congruent, angles are congruent, then the triangles are also congruent, and we denote the congruency of these two triangles here. Triangle ABC is congruent to triangle PQR. And student, observe here, while writing the congruency of two triangles, we have to follow the order of correspondence. Means, observe here, means we can write the first triangle in any order, but while writing the second triangle, we have to follow the correspondence. See here, in triangle ABC, here A corresponds to P. A corresponds to P, means first letter here A, and in triangle PQR the first letter is P. Next, B corresponds to Q, so here the second letter B, then here also second letter Q, because B corresponds to Q. And next, C corresponds to R, means here the third letter C and here third letter R, because there is a one-to-one correspondence between the vertices. So we have to follow the order while writing the second triangle. Means we can write the first triangle in any order, but it affects on the second triangle because there is a one-to-one correspondence between the vertices. Now see, here the triangle BCA is congruent to triangle QRP. Children, observe here, B corresponds to Q. So here the first letter B and here first letter Q. Next, C corresponds to R. So here the second letter C and here also second letter R, because there is a one-to-one correspondence between C and R. Next, A corresponds to P. So here the third letter A and here third letter P. So triangle BCA is congruent to triangle QRP. But the triangle BCA is not congruent to triangle PQR, because there is no one-to-one correspondence between B and P. So remember the students, follow the order of correspondence while writing the second triangle. Now see one more example. Triangle CAB is congruent to triangle RPQ. The previous concept of correspondence. C corresponds to R, A corresponds to P, and B corresponds to Q. So triangle CAB is congruent to triangle RPQ. Sides are congruent and angles are congruent in two triangles, then the triangles are congruent. Now see here, if the two congruent triangles are given, see here the triangle DEF and triangle QRP, these two triangles are congruent, then what happened? See, let us discuss here. If two triangles are congruent, then their corresponding sides, the three sides, and corresponding angles, three angles, are equal. Means if two triangles are congruent, then the three pairs of corresponding sides are equal and three pairs of corresponding angles are equal. See here the triangle DEF and in triangle PQR, these two triangles are congruent, then the three pairs of corresponding sides are equal and three pairs of corresponding angles are equal. Nothing but these are the corresponding parts of these two congruent triangles. and we write like this. The 6 equalities means 3 sides and 3 angles are between the corresponding parts of congruent triangles. Its short form is CPCT. CPCT means corresponding parts of congruent triangles. So CPCT means corresponding parts of congruent triangles. See how to use the concept of CPCT while solving the problems. I explain with a simple example. For example, if triangle DEF and triangle PQR are congruent, these two triangles are congruent from CPCT. What we have from CPCT? See, two triangles are congruent, then the 3 pairs of corresponding sides are equal. Means I can select any one side. See children, once again, if two triangles are congruent, then the 3 sides, the corresponding 3 sides are equal. Now among the 3 sides, I can select any one of the side. So here I am selecting the side EF. Observe in the picture, EF is corresponds to QR. EF is corresponds to QR. So EF equal to QR. Now same, triangle DEF is congruent to triangle PQR. These two triangles are congruent means we can select the 3 pairs of corresponding angles are equal. So among the 3 angles, I can select any angle. So here I am selecting the angle F, its corresponding angle is R. So these two angles are equal. These two angles are equal. So angle F equal to angle R. Now let us discuss some problems from textbook. Here the triangle ABC, AB of 5 cm length, BC 4 cm length, CA 3.5 cm length. Now the second triangle, triangle PQR, PQ 5 cm, QR 4 cm and RP 3.5 cm. Now students, identify the corresponding sides. Here AB 5 cm, its corresponding side is PQ because it is also 5 cm. Next BC 4 cm, its corresponding side is QR because it is also 4 cm. Now CA 3.5 cm and here RP 3.5 cm. So now students, see, follow the order from here AB, BC and CA. 5 cm, 4 cm, 3.5 cm. Now in the same way in triangle PQR also, first PQ, QR, RP, 5 cm, 4 cm and 3.5 cm. Means here there is a one-to-one correspondence between the vertices. Here vertex A corresponds to vertex P, vertex B corresponds to vertex Q and vertex C corresponds to vertex R. So here triangle ABC is congruent to triangle PQR. See the second triangle, triangle DEF. Now students, same, identify the congruent sides. See AB 5 cm, here DF 5 cm, BC 4 cm and its corresponding side is here DE 4 cm, CA 3.5 cm, here FE 3.5 cm. Now is the triangle ABC is congruent to triangle DEF? I explain it why it is not correspondence. AB 5 cm, BC 4 cm, CA 3.5 cm. If I start from the letter D, DF 5 cm, next FE 3.5 cm but not 4 cm, AB, BC, CA. If you start from letter D, DF, FE, ED 5 cm, 3.5 cm, 4 cm, but not the order 5 cm, 4 cm, 3.5 cm. So if I start with the letter F, now students observe here, FD 5 cm, DF 4 cm, EF 3.5 cm, means 5 cm, 4 cm, 3.5 cm. So there is a one-to-one correspondence between the vertices. A corresponds to F, B corresponds to D and C corresponds to E. So triangle ABC is congruent to triangle FDE. See the third example. Here the triangle GHI. Now students, identify the corresponding sides. AB 5 centimeter, here GH 5 centimeter, BC 4 centimeter, here GI 4 centimeters, because the corresponding side of BC is GI, because their length measure is same. Next CA 3.5 centimeter and its corresponding side is IH 3.5 centimeter. Now my question is the triangle ABC congruent to triangle GHI? Again my answer is same, no, because the triangle ABC is not congruent to triangle GHI. See once again, AB, BC, CA 5 centimeter, 4 centimeter, 3.5 centimeter. If I start with the letter G, GH 5 centimeter, okay, but HI 3.5 centimeter, but we need 4 centimeter here. So this is not congruent. If I start with letter HG 5 centimeter, GI 4 centimeter, IH 3.5 centimeter. So there is a one-to-one correspondence between the vertices of vertex A is corresponds to vertex H, vertex B is corresponds to vertex G, and vertex C is corresponds to vertex I. So triangle ABC is congruent to triangle HGI. Now see the last example. Here the triangle STU of all equal sides 5 centimeter. Is triangle ABC congruent to triangle STU? No, because here we can easily observe the triangle ABC is a scalene triangle and triangle STU is an equilateral triangle. So they are not congruent. So triangle ABC is not congruent to triangle STU. Now activity. Students, here activity based on the class. Two circles are always congruent. Now is the statement right or wrong? Read the question once again. Two circles are always congruent. No, because the two circles of equal radii are always congruent. Here the radius is not given, so two circles are always congruent is not correct. Now second, the two line segments of the same length are always congruent. Is the statement is right, because their measure the length are equal. Now third one, two squares are always congruent. Children, read the once again. Two squares are always congruent. No, the two squares of equal length are always congruent. So this is a wrong statement. Now, two equilateral triangles with their sides equal are always congruent. See once again, two equilateral triangles with their sides are equal are always congruent. Yes, if the sides are equal, two equilateral triangles are congruent. Now see the second activity. Figures having the same size and the shape are known as dash figures. Yes, congruent figures. Now, if triangle MNO is congruent to triangle XYZ, then the angle N equal to. So here what is the corresponding angle of angle N? Now observe the students, angle N corresponds to X. So angle N equal to angle X. Now see, if triangle DEF is congruent to triangle XYZ, then the side ZX is corresponds to. So identify the congruent side of ZX. ZX, see here, ZX, D corresponds to X, E corresponds to Y, F corresponds to Z. So ZX means FD. FD. So ZX equal to FD. Now see the last one. If the triangle DEF is congruent to triangle XYZ, DEF is congruent to XYZ, then the triangle FDE is congruent to. There is a one-to-one correspondence between the vertices. D corresponds to X, E corresponds to Y, F corresponds to Z. So triangle FDE is corresponds to triangle FDE is corresponds to triangle ZXY. Triangle FDE is corresponds to triangle ZXY, because we have to follow the order of correspondence while writing the second triangle. For better understanding of the concept, solve the worksheets and please visit the official website of SCRT for worksheets, and also clarify your doubts with your concerned teachers. Thank you for watching the video. Children, we will meet in the next session with one more interesting topic, congruency of triangles. Thank you.